Welcome to the session techies. My name is Yogesh. In last sessions, we had talked about Kubernetes basics and how you can create Kubernetes cluster. This session is going to be on Kubernetes pods. We will have quick introduction, then how to create Kubernetes pod and how you can manage the pods. So this is agenda for this particular session. One thing I want to request, in case you are not clear on Kubernetes concepts and how to create or set up a cluster, then please watch the previous videos which I recorded on Kubernetes. That will give you idea, and that will help you to understand this particular session very easily. So that's something I'm requesting, and let me begin this session. So Kubernetes pod. A Kubernetes pod is a group of one or more containers that are deployed together with the configuration to run containers. Couple of points about pods, and they are very important points, guys. We need to understand the pods. So these are going to help us to understand pod in a better way. Pods don't have a managed lifecycle. If they die, they will not be recreated. Pods are actually not only containers, because many guys think, okay, pods are container only. No, pods are one layer above the containers. I will come to this particular point in the next slides. The host name is set to pod's name for the application containers within the pod. What it means now, if you create a pod, automatically the pod members or the pods will get a prefix of whatever application name you defined or pod name you defined. That will be prefix, so you can easily identify what is the particular pod application name. Each container in pod is assigned with its unique IP address. This is not something different feature, but I thought to get it documented so you will be aware. Basically what it means, let's say in single pod you got 4 or 5 replicas. So each replica or each container will have its unique IP address. The individual container may be versioned, rebuilt, and redeployed independently. It means, let's say in the single pod, you got 2 different images. One image may be version 1, second image may be version 2. In that case, you can use different images which may be versioned. You can update the image on your machine and redeploy the pod, and it will pick the new configuration. Pods are not durable entities. They won't survive scheduling failure or node failures. When a pod is scaled out, all the containers within it are scaled as a group. It means, let's say in a pod you got 5 containers. You have defined it need to have minimum 5 containers. And if you scale up the group with the new configuration, then automatically all the pod members or pod containers are going to get new configuration. So no need to do the changes on individual pod member. That's again great feature of Kubernetes. Now let's talk about how to create a pod. There are 2 methods. One is using kubectl run. Second method is using a YAML file. So let's talk about how you can use kubectl run to create a Kubernetes pod. In this example, we are going to create a pod with name nginx-lab-cli. Docker image nginx will be used. All container in the pod will be exposed to port 80, and 2 containers or replica of 2 will be created in the pod. To create a simple configuration, I thought to make things simple. So you can run kubectl, which is the Kubernetes command. Run is basically the option which we are using. This is going to be pod name. Image -- image is equal to image name. That's image we are going to use -- port 80, because containers will be exposed with this particular port. -- replica 2, it means 2 ports or 2 containers will get created. If you want detailed information, this is something I have got from man pages of kubectl command. That image we already talked about. Environment is something if you want to define some variables. -- port we already talked about. Replica we talked. Dry run, basically it will not make changes, but it will tell you what changes it is going to deploy on the machine, or what changes kubectl is going to make. Override, if you want to override the generated object. Command is something if you want to pass something for Docker to run during Docker creation or Docker boot up. This is similar to Docker command, which we define in the Docker file. So you can assume that's similar. And after that, you can specify arguments. Another thing, guys, which you need to take in mind, that when you define replica, like here I'm defining replica 2, Kubernetes creates a deployment. Basically, deployment is something which will create a replica set. And the purpose of replica set is always to maintain number of pods to be in a running state. For example, here I have defined number of replicas 2. So Kubernetes will make sure there are always 2 pods in the active state or running state in this particular Kubernetes setup. So that's something, again, a Kubernetes feature. Let's have a quick technical session where I can demonstrate how you can create a pod, how you can access it. Then I will jump to the second method of creating pods. So let me open PODS session quickly. Okay, so I'm on my master server. First of all, guys, before creating pod, I want to make sure that using Flannel network, I'm able to communicate with the nodes as well as master. So let me pick this particular node. This is my Flannel IP and this is my Docker IP. So let me ping this particular Docker and see I'm able to ping or not. It's good, I'm able to ping. So what changes I have made to make this communication working? I have enabled IP forwarding. For that, you can simply run echo pass this particular parameter to this particular configuration file. That's a rel 7 way. Earlier it was in etcctl.conf. After that, I am just applying the changes. So it's done. Let me do it on all nodes. I think I have already done it on one, but let me repeat. Yeah. So let me repeat. Here it's done. Here it's done. So I will be still able to ping this one because I have deployed the changes. Yes. So communication is working. That's communication is important to work because that's Flannel network, which is for inter-node communication for the Docker containers. Okay, so let's create our first pod. What are the things which need to be checked before starting a new pod build? You can verify whether nodes in that particular cluster are ready or not. For that, you can run kubectl get nodes. Okay, nodes, you can see both nodes are ready. So it means we can create the pods and both are ready and scheduling is not disabled. So that's something good. Oh, another thing, if you want to check what are the pods already created on this machine, because maybe you are only thinking you don't want to repeat the names, right? So you can run command kubectl get pods. Right now no pod is created. That's something good. So let's create our first pod. Kubectl run nginx-lab-cli. This is pod name. This is image I'm using, and this image not required to have on master server. This image is required on the node 1 and node 2. In case this image is not available, then automatically this image will be getting downloaded by the Kubernetes mechanism, basically Docker. Kubernetes push Docker to pull this image from Docker registry. And sometimes it use Red Hat registry also. Port 80, this port will be exposed. Replica 2, it means 2 ports will be created. You can see this deployment is created, and let's verify what is the state now. You can run command get ports. You can see containers are getting created. 0 completed. So one task, it's still going. It may take a couple of seconds only. Okay, you can see now both the ports are running. As I mentioned, because this was the application name or pod name, that will be prefix, and this is the identifier for that particular port. So 2 ports are created and they are running. So Let me quickly tell you how you can check what is the IP address of port over the container. From master, simply run same command, kubectl get ports, just add another switch -show white. It tells you for this particular port state is running. 50 seconds before it went up or came up, this is the IP address of port, and this particular port is hosted on this particular node. You can see when we kicked off build, Kubernetes automatically distributed both ports on two different servers. So that's Nginx server. So we have already exposed port 80, so it would be listening on port 80. So let's check. I can run curl http and this particular IP. Let me define port also. By default it will go to 80 only, but no harm. You can see I got response that this is Nginx. And let me try the second server also. You can see I'm getting page. So it means my container creation went fine. I'm able to access the ports from different server because I'm on master and ports are running on node. So it means my configuration looks good and it worked. Containers or ports are good created. It's something good. So after kubectl run method, let me talk about creating port using YAML file. We all know YAML is basically text file in YAML formatting. So in this example, we are going to create a port with name nginx-demo-YAML image, same image, nginx image we will be using, and container will be exposed to port 80. So not much changes. Only thing I'm not running this particular YAML with replicas. I just want to show you how you can create a single container port. -- here mean that start of YAML file API version. I'm using v1 because that can be called using API, the particular YAML. In metadata, I'm saying this is going to be name of this particular port, and labels, I have added label. I'm saying app, that's Nginx web. So you can have multiple labels. In specs, I'm saying container, use container. Name of container is going to be Nginx demo YAML. Which image to be used? Nginx. Ports, I'm saying container port need to be 80. So this port will be exposed. To create a port, simply run kubectl create -f, this particular YAML file, and port will get created. Other options which you can use in the YAML file, they are name, image, command, arguments, working dir, ports, and volume mount, lifecycle, termination message, image pool policy, security. So these options are something which you can use for deeper understanding of port. I'm not going to cover everything because this session is just quick introduction. One important feature I want to tell, which is image pool policy. Image pool policy is basically whenever you create a port, if image is available locally, then you have to say image pool policy false. So it will not go to the Docker registry or Kubernetes registry to download the image. It will see, okay, image is already available locally, so don't download the image. That's something good to know. So let's create a YAML file and kick off the port build using that particular YAML file. Let me bring up the putty session. So I'm on master. Let me get ports. Right now the two ports are running. They got CLI with the name. So new ports we are creating, they got YAML in the name. So first of all, create a YAML file. All the things I'm doing that they are on master. Escape I. I'm just copy pasting the YAML file which I created earlier. I already talked about what are the options, what they mean. So I'm just saving the file. And to create a port, kubectl create -f and the YAML file. Press enter. Okay, I got error. It is saying invalid field container port. So what it means, my formatting may be wrong. YAML formatting may be not in proper way. Let me edit this file quickly and see. Okay, so what's wrong here in ports, because container port is a property of ports, so I have to format it correctly. Now it looks good to me, it should be working. If not, that's something wrong. Okay, you can see this particular port got created. Let's check whether that port got created or not. Okay, you can see this particular port is created and that's in running state now. And Kubernetes picked this particular node 2 for the deployment, and this is the IP address. Every port got unique IP address. Let me access this port using IP address. I'm running same curl command, and let me replace it with IP3. You can see I'm able to access the port, and within 5-6 seconds my port was ready in running state. That's the reason Kubernetes is popular, Docker is popular. Deployment is very easy and quick, and within a couple of seconds the applications are ready. So that was the way how you can create a port using YAML file. And let me talk about a couple of management things, how you can manage the ports. In the management, I'm going to discuss a couple of commands which are commonly used. First two commands we already discussed, how you can get ports, how you can list out the port IP address and on which host they are hosted. Other commands, if you want to get detailed information about port, you can run describe port with port name. Then if you want the output in JSON format, you can run in this way, get port -o JSON and port name. If you want to delete a port, you can run delete a port kubectl delete port name. If YAML file is present, let's say you have created a port using YAML file and YAML file is present, you can simply delete by specifying YAML file kubectl delete -f YAML file. To delete a port immediately means that will be not graceful shutdown. I don't think that is going to be issue. Then you can run kubectl delete port and port name, foo is port name -- now, it will immediately delete. If you want to delete all the ports, you can run command kubectl delete ports -- all. Please note, if you got deployment created using kubectl, you have to delete the deployment too. Okay, let me quickly demonstrate these commands to you. So first of all, let's list out the ports which we got. Okay, -o. Okay, we got 3 ports. So first of all, let me describe one port and tell you how you can get the detailed information about the port. Kubectl describe ports space port name. Let's check this particular port. You can see all it gives detailed information. This is the name of port, default namespace. On this particular node it's hosted. This is the IP address of node. At this particular time, this particular port was started. App name is nginx web, which we defined in the port configuration. If you remember, that was label. Status is running. This is the IP address. Controller is nothing because that's a single deployment. That's not a RC or application controller deployment. In the container configuration, it got this particular container ID. This image was used. This is the image ID. And this particular port is exposed. State is running. It started this time. Ready, true. Restart, 0. Conditions, type, status, initiated, ready, true, port schedule, true. And you can see these were the steps which done and how long they took to finish. Port was created, containers created, container started. So everything is documented here or displayed here. In that way, you can get information about the port, basically detailed information. If you want the information in the JSON way, for that case, kubectl get port -o JSON and port name. So let's pick this port only. So you can see all the information in a JSON format. So that's something good. If you want to delete a port, so to delete a port, kubectl delete port, then you can specify the name of the port. so that port got deleted. So that's simple. Let's list out the ports quickly. You can see now we got only 2 ports. So that's something how you can delete the ports and how you can get more information about ports, how you can describe the ports. So guys, next video is going to be on replication controllers and resource management inside Kubernetes. So do practice. I think that's something different. This tool is something different, but that's not difficult, easy to understand. And the agenda of this particular session is only to give you basic understanding. After this session, you are not going to be expert, even I'm not. So this is only for very basic understanding. So you will be aware what is Kubernetes, what basic things it can do. So thanks for watching this video. Stay tuned for next videos. Thank you guys. Bye-bye.